Welcome to Ask and Learn.
So they give us these 4 coins and they tell us one of them is counterfeit. And what we want to do is figure out the least number of weighings we need to do in order to ensure that we found our fake coin. But more than that, we want to be able to say if this coin is lighter or heavier than our real coins. So let's think about this. So when we weigh the coins, there's three decisions that can be made. And I'm going to call these decisions because these are going to be the edges of our tree that we're going to construct. So there's three. So we can have where one side is greater than the other, they're equal, or it is less than. Then the number of options for our final result of this fake, well, we can have where four of them are the fake, but then each of them can also have three options of whether they are real, and then if it is the lighter or the heavier. So this would give us 12 in total. So then we would do log base of our decisions of our options. And so then this is something around 2.2. And then they tell us to just go ahead and take the ceiling of this, and then that gives us 3. And so they tell us this formula here in the example in the chapter where they're talking about the coins. So if you want to go and read up on it more. Okay. So now let's see if we can actually figure out how to sort these though, because we need a algorithm. All right, so let's see. So I would just start by comparing 1, 2, and 3, 4. So let's say the left side is heavier. So 1, 2 is heavier. Well, at this point, what I would do is I would compare 1 and 2. So let's do 1 and 2. So we could have where 1 is larger than 2. So if this is the case, that means 3 and 4 are going to be equal to each other. Since remember, we only have where one of these is going to be heavier or lighter than the rest. All right. So then that means 1 is the fake and it is heavier. All right. Then we could also have the case of where 1 is less than 2, or actually I'll do it this way. So just 2 is greater than 1, just to keep with the greater theme. So then again, this means 2 is fake and it is heavier. All right. But then we could also have the option of 1 and 2 weighing the same. All right. Well, if that's the case, then we should compare 3 and 4, because that means 1 and 2 are the real ones. So we do 3 and 4, and then if 3 is larger than 4, then this means 4 is fake and it is lighter. And we know it's lighter because remember, this first step we said that 1, 2 is heavier than 3, 4. And then likewise, if we have that 4 is heavier than 3, that means 1, 2, and 4 are all the same weight, and 3 is our fake. And then this is the case of where it's fake and lighter. All right, so you can kind of see the algorithm that we would have here. So what I'm going to do is I'm going to write the algorithm down first, and then if you want to complete the tree, you can stay for the rest. All right. So let's see, our algorithm is going to be this. So split into two groups of two. Or actually, before we say this, we need to make sure that this actually was 3 wings, because that's what we said up here, that at a minimum, this is how many steps it would take to ensure we got this. So this was 1 wing. Here we had 2 wings, and then here we had a third. So notice that these 2 wings here only had 2 steps to them, which is still fine, because that was within our threshold of at least 3. Because you could also just do a random guess, pull 2 out, hope they're right, and you could get this in 1 as well. But we can't ensure that we'd get it in 1, and we can't ensure that we'd get it in 2. So that's what this means. All right. So then we split into 2 groups of 2. So then take the heavier group and weigh. So if one is heavier than the other, we have found the fake, and we know the fake is heavier. If not, then, or so if they're the same weight, so if the heavier set is the same weight, we know our fake then must be lighter. So weigh the other set of coins, and the lightest is our fake. So this would be the algorithm to ensure that we always find it within 3 steps. So if our fake is heavier, we find it in 2. If it's lighter, we find it in 3. All right. So now let's go ahead and finish this tree though. And if you're not interested in finishing the tree, then you can just go ahead and head out. But I feel this is pretty important, seeing as this is the whole idea of this chapter, is to use these trees and actually show the application of them, as opposed to just saying things in words. All right. So let's go ahead and do this. So we could have the case, or we couldn't have the case, I should say, of where 1, 2 is equal to 3, 4. Because if 1, 2 is equal to 3, 4, then that means they're all the same, which would be a contradiction of one of these being a fake coin. So we don't need to worry about that case. And then over here, we would check where 3, 4 is greater than 1, 2. All right. So then what did we do over here? Well, we weighed the greater. Oh, I should write 3, 4 right here. So we weighed the greater of them, so 3, 4. And then we compared these. So if 3 is larger than 4, then 3 is the fake, and it is heavier. If 4 is larger than 3, 4 is our fake, and we know the fake is heavier. And then if 3 is equal to 4, then that means we will have to now check 1 and 2. And then remember, our result is going to be one of these is lighter. So if 1 is greater than 2, that means 2 is fake and lighter. And then over here, if 2 is larger than 1, then that means 1 fake and it is lighter. All right. So this would be that whole tree for the decisions that we could possibly make.